Hello everyone. Let's continue with our past lesson, and it was about introduction to computer, and we left over with the software and the summary, and we're going to talk a little bit about the communication, and we will continue with the ALU. Now, software. The computer is divided into two. One of them is hardware, and the second one is software. Software, the operation of your computer is controlled by a system software. The system software is stored in the computer memory, which instructs the computer, which tells the computer to to load and store and execute the operation that you are given to the computer. So it gives the control, like you make a control of the computer. And we have to say that the computer doesn't understand the human language, the human being language. It does understand the machine language. So our language is converted to machine language, which is 0, 1. So anything you type, any memory that you do, any folder that you save, this action is saved on the computer, and the computer, there is a compiler in the computer that transfer your words or your data or anything to 0 and 1. So it's an instruction, and there is a compiler to transfer it, to convert it. Professional programmers write a variety of application software to satisfy needs of the public who wants to perform specific tasks on their computers. The basic types of application software are word processing, database, spreadsheet, and desktop application and communication. Operating system is the most important software on the computer, and it controls and manages the hardware connected to your computer. Provides an interface that helps you to interact with the computer, ensures that your computer is functioning properly. Windows XP and Windows Vista, Windows 98, Windows 7 is one example of operating system. So your computer can be Windows 10 or Windows 7. You have to know which your computer, which Windows you are downloading, which operating system that you are working on. Can be either text-based, graphic-based. A graphic-based operation system helps you to install hardware or software with easy-to-use interface. Programs, the hardware and the operating system together are referred to as platform. Programs, also called application, used to this platform perform task. And there are many types of programs. Some programs allow you to perform tasks such as writing letters or doing calculations or sending email by using the network or internet messages. Other programs allows you to create illustration, play games, watch movie, or communicate with other computer users. And now we are big, and before I come to that, and I want to explain that there are two types of software in the computer. It's system application and system software and application software. And data, we have to know that data, that the memory that you make or any folder you save or any Word file or any type of memory you make in the computer goes as we call it as a data. So you save your data or processing data. Program as a processor data you provide as an input to your computer. Data can be in the form of text, graphs, audio, or video, depending on the type of the program. So if you are making a video or recording a video like we are doing now, you are saving video data. So this data you are saving the computer, it's memory. So this is how the computer works actually. Programs processor the data and display the output and the screen. You can save this input in a file. And the file can be audio file, text file, graph file, or a video file. Summary of this chapter, chapter 1. Computers are repeatedly changing the changing world we live in, and we used to talk about the changes made in generation. So there is generation made in in the computer. Now we see changing from year to year. It used to be from 10 years to 10 years. No, now every year we have seen like different changes in the computer. Let's say laptop, PC. So there is big difference. All computers have server parts in common. Video cards, sound card. We all share this in the same computer, whatever you use an old computer or a new computer. Input devices which allow data and commands to be entered into your computer. A means of storing commands and data. A central processing unit which controls the processing. And the last one, a means of returning and processing information in the form of output. So that's it for our last lesson. And now we will come to our new lesson, and which is about ALU. What is ALU? ALU is arithmetic and logical unit. Arithmetic, we mean by arithmetic, it's an add-in or subtract or multiply or division processing. And logical, it's about gates actually. It's about how you use the ALU, how it works and how it runs. So ALU is a digital circuit used to perform arithmetical and logical operations. It represents the fundamental building block of the central processing unit, CPU, of a computer. Modern CPUs contain very powerful and complex ALU. And in addition to ALU, modern CPUs contain a control unit, CU. So CU is a control unit, which is run information or shows how to run the operation in the ALU within the CPU processor. Most of the operation of a CPU are performed by one or more ALU, which is load and store data in a register. And a register is very small storage in the computer. So you can, if you do like one operation in the computer or one structure, it might save in the register at that time, and then it runs automatically to another instruction. So it has to wait to perform data, and the ALU stores the result in an output register. The control unit moves the data between these registers, the ALU and memory. An ALU performs basic arithmetical and logical operation. Example of arithmetical operation, as I said before, addition, subtract, multiplication, and division. An example of logical operation, we say like NOT gate, AND gate, XOR or OR gates. There are many, but we are gonna talk about only 4 gates today. So we will talk about this later on. All information in computer is stored and multiplied in the form of binary numbers. So the computer doesn't understand our human language, human being language. So it converts to binary number, binary code, which is 0 and 1. So wherever you do or whatever the operation that you do, it's about 0 and 1. It converts to 0 and 1. There is a compiler to convert this. An example, 0 and 1. Transistor switches are used to multiply binary numbers, since there are only 2 possible states of a switch, open and close. Let's say, which is like how the computer understanding. This room, we have a light. If you put the light on, that's mean 1. If you put the light, you turn it off, you turn off the light, that's mean 0. So this is high voltage, 1 is high voltage, and 0 is low voltage. So 1, turn the light, it's 1. 0, turn off the light. So it's high voltage and low voltage. An open transistor through which there is a current, no current, represents 0. A closed transistor through which there is a current represents 1. How an ALU works, operation can be accomplished by connection multiple transistor. So multiple transistor or one transistor can be used to control a second one. In effect, turning the transistor switch on or off depending on the state of the second transistor. This is referred as a gate, and which I'm going to talk about only today, or the gates, AND gate, OR gate, XOR, or NOT gate. Because of the arrangement can be used as follow to allow or stop current. This picture shows us the gates, how it works, and they can be combined together like AND gates. Let's see in here, like AND gate or NOT gate are all combined together to show you or to make a result for you, to make an output of your operations and the computer. Now we are going to talk about the types of gates. The simple type of gates we are going to talk about, it's NOT gate. And this is used only a single transistor. So it's single transistor, which is, it takes only one input and it gives you only one result, only one output. So one input and one output. As I said before, like the room light, on or off, 1 or 0. Single processor output, which is allow the opposite of the input. So it's always the opposite. Wherever is the input, so it's the always like the opposite. So it's if your input is 1, so if we use NOT gate 1, NOT gate it's 0. If it's 0, so whatever the 0, it's the opposite. So 0, the output will be 1. This is how it goes in NOT gate. Other gates consist of multiple transistor and use 2 input, like AND gate, 0 and 1. I'm gonna explain this later on, or we're gonna come to explain this now. The OR gate result, it's in 1, if either the first or the second input is 1. The OR gates only result in a 0 if both input are 0. This figure will show us the logical gate of OR. Now let's explain the NOT gate. As we see here, we have to memorize, or we have to know how each gate looks like. So I'm gonna maybe ask about this in the exam, but you have to memorize how each gate looks like. Like let's see this one, it's NOT gate. Only one input and one output. So this is how it goes. NOT gate, let's see, it's our input is 0. So not 0, what is the result? It's 1. And if we have the result 1, not 1, the result output will be 0. So this is how NOT gate works. Input and output, input and result. It's either high voltage or low voltage, 0 and 1, 1 and 0. So not 1 is 0, not 0 is 1, it's the opposite. And now I will talk about AND gate and I'll explain it to you. AND gate result in a 1 only if both the first and the second input are 1s. The figure will show the logic of AND gate. Here, we have to memorize first of all we have to know how AND gate looks like. So we have 2 inputs and 1 output, 2 input and 1 result. So if we said 0 and 0, the result will be 0. 0 and 0, the result will be 0. And if we have 1 and 0, the result will be 0. And so it's an AND gate. 1 or and 0, the result will be 0. 0 and 1, the result will be 0. 1 and 1, the result will be 1. So this is how AND gates goes and how it works. 2 inputs and 1 result. And as we see here, let's say for each input, we have 1 result, but each value is different here. 0 and 0, it's 0. So when the input are the same, the result is the same as well. Let's see here, 0 and 0, the output is 0. We come to the last one. 1 and 1, it shows us the result that it's 1. I'm sorry, it's 1. So this is how AND gates work. And now we are talking about OR gates. So all our gates, it takes only binary number, 0 or 1. It doesn't take 5 or 6 or 8. So it takes only 0 number. It can take a word. So you have to, computer takes it at 0 and 1. OR gate, let's come to OR gates. 2 input and 1 output. And we have to memorize, or we have to know how it looks like, the OR gate. 0 and 0, the input, 0 or 0, the result is 0. 1 or 0, 1. 0 and 1, it's 1. 1 and 1, it's 1. So each time you have 1 in the input, or both inputs are the same, the results are the same, like 0 and 0, it's 0. 1 and 1, it's 1. So this is how OR gates work. Let's see here, we have 2 inputs, 1 and 0. The result will be 1. So it doesn't be 0 because we are talking about OR. 1 or 0, we refer 1, so the result will be 1. 0 and 1, the result will be 1. And now we are talking about XOR gate. The XOR gate, also pronounced XOR gate, result in a 0 if both inputs are 0, or if the both are 1. Otherwise, the result is a 1. The figure now, which shows us how it works. So this is how it looks, the XOR. So it's different here. There is a line between the 2 inputs. This is how XOR gate, not like OR gate. See, it has to be here a line. This is the difference between OR and XOR. So 2 values, 2 inputs, and 1 result. All of the gates, they have only 1 result. But it can be 1 input or 2 input, like in NOT gate. 0 and 0, it shows us 0 and 0. 0 XOR 0, it's 0. 1 XOR 0, the result will be 1. 0 XOR 1, the result will be 1. 1 XOR 1, the result will be 0. So if they are the same, the result will be 0. The first one and the last one, always look at these two. 0 and 0, the result will be the same. It's 0. 1 XOR 1, the result will be 0. So if it's the same inputs, the result will be 0, no matter what. If it's 0, 0, the result will be 0. 1 and 1, 1 XOR 1, the result will be 0. But if we have 0 and 1, 0 XOR 1, the result will be 1. 0 XOR 1, the result will be 1. And this is how it works in our gates. But I want to explain something about our chat before I end this class, this lesson. I posted chat time yesterday at 6 p.m. The time was on Cyprus time. And until now, like yesterday, I didn't see no one for the chat. Please, if you have any information or any question you want to ask, do it during the chat. And the midterm is going to be about, we decide this later, but it's going to be about 3 lessons, not 1 lesson or 2 lessons. It's going to be about 3 lessons, and I assigned 1 assignment for you, and it's from 5 marks. Please check into your site and check your email as well. Thank you so much for today. I see you next week, hopefully.